Let's go ahead and take a look at our next function. This time we have the cube function. So we're going to be working with the equation y equals x cubed. And let's go ahead and take a look at 3 points on this graph. We have the point 0, 0. We have the point 1, 1. And we also have the point negative 1, negative 1. You can also use points like 2, 8 or negative 2, negative 8 on your graph as well. Let's go ahead and take a look at the domain. We want to know how far left and right our graph is going. So this graph will be going left and right forever. So we've got from negative infinity to positive infinity. The range, how far up and down our graph is going. It's going to be going downward forever, so all the way to negative infinity. And it'll be going upward forever, all the way to positive infinity. And let's go ahead and take a look at where our graph is increasing. Remember, increasing graphs are going uphill as you look at them left to right. Decreasing graphs will be going downhill as you look at them from left to right. So as we look at this graph, this whole section is where our graph is increasing. Right? It's going uphill as we look at it from left to right. So it is increasing on this entire interval from negative infinity to positive infinity. And this graph will have no intervals where it's decreasing. Our next graph is the cube root function. So we've got the equation y equals the cubed root of x. If we take a look at 3 key points on this graph, we're going to be working with the point 0, 0. We have the point 1, 1. And we also have the point negative 1, negative 1. Those will be the 3 key points on our parent function. As we look at our domain, we want to know how far left and right our graph is going. Our domain will be from negative infinity all the way to positive infinity. The range, how far up and down our graph is going, will also be from negative infinity to positive infinity. And for our increasing piece, we want to know where the graph is going uphill as we look at it left to right. So this whole section of our graph is always going to be increasing. So it's increasing on this entire interval from negative infinity to positive infinity. Decreasing functions will be going downhill as you look at them from left to right. This function does not have any spots where it's decreasing, so there are no intervals where it's decreasing. Our next function is the absolute value function. We're going to be working with y equals the absolute value of x. So let's go ahead and take a look at 3 key points on this graph. We have a point here at the origin. So we have the point 0, 0. We also have the point 1, 1. And we have the point negative 1, positive 1. You can pick a few other key points if you would like to. If you want to use 2, 2, or 3, 3, you could use those as well. Go ahead and try to fill out the rest of this chart on your own and submit it with your notes. Feel free to pause the video at this point so you can complete the chart. And let's go ahead and take a look at our last function. This one is the reciprocal function. We're going to be looking at the equation y equals 1 over x. And these functions are going to be coming to us in fraction form. So we're going to want to make sure we're paying attention to the values that are in our denominator, accounting for any values where it would make an undefined fraction, right? We don't want 0 in the bottom part of our function. So let's go ahead and take a look at some key points that are on this graph. We have the point 1, 1. We also have the point negative 1, negative 1. Notice we can't use 0 because that would make an undefined fraction in this case. So we can go ahead and pick another value to find a third key point on this graph. So let's go ahead and use an x value of 2 and take a look at what happens. If I pick an x value of 2 and plug it into my function, then my y value here is going to be 1 over 2, or 1/2. So I'm going to go ahead and use the point 2, 1/2 as a third key point for this function. Let's go ahead and do domain and range together on this one. Domain would be any x values with regard to our graph. We want to know how far left and right our graph goes. Notice in this case, x cannot be equal to 0 because that would produce 0 in the denominator of our fraction, and we don't want that. So when we're working with our domain, we can use any other x value except for 0. So we can go from negative infinity all the way to 0. I don't want to include the 0 itself, so I'm going to go ahead and give it a parenthesis. And then it's going to pick right back up at 0 and keep going all the way to positive infinity. Notice I have parentheses on both of those zeros when I write my interval notation. When I'm looking at the range, I want to know how far up and down our graph is going. Notice that I'm not allowed to have a y value of 0 in this case either. It doesn't cross that x-axis at all. So my graph is going all the way from negative infinity up to 0, but I'm not including the 0. And that's going to pick right back up and go from 0 to positive infinity. Let's take a look at where the graph is increasing and where it's decreasing. Our graph is going uphill from left to right. It's increasing. If it's going downhill as we look at it left to right, it's decreasing. So when we look at this graph, let's move left to right here. This is a portion where our graph is decreasing, right, over this entire interval here. So this is going to be the interval from negative infinity all the way to 0. And then if we take a look at our second piece of this graph, I'm going to look at it from left to right, so this graph is also decreasing over this entire interval. So from 0 all the way to positive infinity. And we don't have any spots where our graph is increasing on this one, so I'm going to go ahead and write none.